Welcome back to the Arkansas Soybean Promotion Board's Soybean Podcast. We are today with Dr. Trent Roberts, Associate Professor of Soil Fertility and Soil Testing at the University of Arkansas. His board-funded project is titled Field-Based Determination of Chloride Tolerance in Soybean.
Well, so our ultimate goal is basically just to give more resolution to the screening process or to the diagnostic process. And why we think that is important is, let's say, for instance, a producer's trying to pick a soybean variety. And he goes, okay, well, I know I need an excluder in this field, but I can't find one with the herbicide traits that I need, or the yield potential, or maybe metribuzin tolerance. So then they could move to a number 2, right, chloride tolerance classification, knowing that they're going to get some benefit.
Get them into some other,
But it may not be as perfect as a 1, but it's still going to be a lot better than a 3, 4, or 5.
Right.
And then the flip side of that is, if they're in an area where chloride's not a problem, then that means they've got the whole spectrum to look at,
right,
and they can really pick and
more
choose.
Options,
So traditionally we've relied on, short growing season in the greenhouse with relatively small plants to try to screen for chloride tolerance. And so several years ago, Dr. Slayton, myself, and some of the grad students started looking at alternatives kind of to this, greenhouse screening. It's also coupled with other things, right? Like herbicide technologies, yield potential, all these other different types of things. And so not being able to really separate those mixed varieties and give producers more options was something that we felt was lacking.
So is the hope then that we go from greenhouse screening to plot sizes here screening, or growers' fields across the state?
Yeah, so what we've actually done is kind of developed a new protocol for a field-based screening, where we actually just collect samples from the official variety trials that are already ongoing, and we can take those samples and use it to categorize the chloride sensitivity or tolerance.
What are the big contributors to higher chloride in soybeans?
So chloride's a plant essential element, right? So the soybean plant needs to have it, but it also, right, if it accumulates a lot in the tissue, it becomes toxic and is a problem. And so different soybean cultivars have different mechanisms. So for instance, like a soybean includer, it just takes up the chloride indiscriminately. So it has no filter or screening mechanism.
Right.
And so that means it's much more sensitive to high levels of chloride in the environment. Whereas when we look at excluder varieties, they have a mechanism to help screen or filter out that chloride. And then when you get to the chloride in the environment, there's a lot of contributing factors, right? Irrigation water quantity, irrigation water quality, and anything that impacts either of those two is going to have a long-term effect, right, on the chloride concentration or buildup in the soil. What we deal with here in Arkansas, and why it's becoming more of an issue, is most of our soils are poorly drained. That's why we grow rice here, right? We can't just flush the chlorides out of the profile. When you look at the volume of water that we apply to fields via irrigation over time, those small concentrations can build up rapidly over 5, 10, 20, or 30 years.
How many options are there in planting season of 22?
That's why we test every year, is because when a new cultivar is released, we want to be able to provide those producers with information specific to that one. But in 4 years, that cultivar is probably going to be gone.
Not even existing.
There's going to be a new one.
So the first signs of this as a toxic level sort of manifest on the end of the leaves to begin with.
We call it scorching, right? With the idea being the plant has too much chloride, it's trying to push it to the edge of the leaf. That's what we're looking for, right? That scorching type of symptomology. Unfortunately, you're losing yield before you ever see that symptomology.
Right.
If you get to the point where you see scorching and you're in an includer or an excluder variety, you've already lost so much yield. I don't want to say catastrophic yield loss, but it's pretty
significant,
bad.
Yeah.
I hear a lot of people say, well, I did everything right in this field. Put out the right fertilizer, I irrigated timely, I had a good cultivar, no matter what I did, I only cut 50 bushel bean. I start to wonder, well, is that a situation where they had this kind of hidden toxicity and the beans looked fine, but they were kind of slowly losing yield due to that accumulation of chloride. And that's where I think, we want to expand this work and just, try to do a survey and see, are there areas of the state that we don't think we have a chloride problem, but we actually do?
Water testing is preferred over soil testing, correct?
Definitely.
Yeah.
If we measure the water source, right, then that gives us a good idea of at least what we're adding. And so irrigation water quality is a good predictor of, whether or not I'm going to have an issue in a particular field. From this point going forward, chloride toxicity is only going to become more of an issue, as we're looking at further constraints on, water quality, water quantity, all those types of things are just going to make this more and more of an issue. If you're just continually adding that salt source, it's just going to continue to build up in the soil. And at some point, even your well-adapted cultivars are going to suffer.
Right. Well, thanks for doing this work, and thanks for your time today. We appreciate what you do, and it's good to see you again, and we'll follow up on this project soon.
Sounds great.
Thanks.
Thanks for listening to the Arkansas Soybean Promotion Board's Soybean Podcast. We hope you'll follow us on Twitter at Arkansas Soybeans and even more resources at themiraclebean.com.